Assalamu alaikum. I am Mahmoud Hassan, ID IT 21019. Here I am today to present on my selected topic, which is number 16, and title is Wireless Chargers Use Electromagnetic Induction to Transfer Power Safely Wirelessly. So here we go now. After hearing the word wireless, right, what comes first in our mind? No wire, right? No wire. That means a mechanism which charges the battery without physical connection, without cable, without wire. So the electromagnetic induction transfer energy between two coils. This is first demonstrated by Nikola Tesla in 19th century, and this technology used in this modern era vastly in smartphone and AV. This is usually this is basically basis on the Faraday's law of electromagnetic induction, which is called a changing magnetic field in one coil induces an electricity nearby another coil. So you can understand that without physical connection, battery and charger, we can charge battery. So what is the mechanism? Here is the visual representation of this process. So in the charger portion, there is a transmit circuit or a transmit coil, which is called transmit coil, and that transmit coil induced electricity nearby receiver coil, which is basically attached with device. And this device also has a receiver circuit, which is convert AC current to DC current, and that DC current charges the battery. So here you can see that the visual representation of this mechanism, electromagnetic mechanism, how it's work. Now we can say the standard. There are mainly basically two standards. One is QI standard and one is PMI standard. But in nowadays, QI standards is in more modern, like QI2 standard, which is basically nowadays used in iPhone 15, 16, 17, etc. And also add MagSafe. MagSafe means is the normally coil aligned by device manually, but in MagSafe it is aligned by magnetically. When we attach the device and the charger, it's automatically aligned in a certain when it comes in a certain region or certain distance. Then comes here we can see that another standard PMA, which is called public charging station. And also with the basic principles, we can already see that in visual representations, the alternating currents in transmit coil creates magnetic field. Alternating currents means AC transfer coil, which is creates magnetic field. Receiver coil inside device capacitor is that magnetic field. Induced AC, which is already converted to DC and charges battery. A key law, which is actually explained that the basic of Faraday's law. Now the components. Also, you can also share this previous slide, the visual representation, where you can see the transmitter coil, which is exactly attached with charging point, receiver coil, which is attached with device, power sources, control circuit, and rectifier circuit, which is convert AC to DC. And working procedure power flows into transmit coil, and then magnetic field key generated, and that's magnetic field induced electricity nearby coil, induced voltage, and that's voltage converted into DC using circuit. Then this DC voltage started to charge battery. Mechanism, how it works, a YouTube short video you can see, and then we can truly understand how it works. Now we can see the advantage. What is the advantage of this wireless chargers, right? If there is no advantage, there is no need to use this. So we have to use according to the advantages, like no wire to use, right? No cable uh, need, and also it reduce wear on ports, water and dust resistant design, and safe and use friendly. There are many advantages also, user friendly and portable, uh, uh, complexity, less complexity, etc. And now you can see some limitations. Though it's modern technology, but it has some limitations like lower efficiency than the wired chargers, slow charging rate, and heating issues, general heat during operation, and need close alignment. I can say, I previously said MagSafe, which is used in iPhone or a similar kind of device, which is exactly a magnetic type of alignment. Previously, this alignment was manually man-made, hand manually aligned, but using MagSafe and QY2 technology, this actually aligned by magnetically. When a certain distance closer the device and the MagSafe, they are automatically aligned. That's called uh, close alignment. Though there is some limitations, uh, uh, then QY2 plus MagSafe is modern technology. There are some limitations, but in future this limitation got reduced. And then application, we can say that already that I am vastly used in smartphone like Samsung, Apple's, electric vehicles nowadays, medical devices, industrial automation. This is technology. This is the future. So there is a huge scope to uh, uh, innovate and to increasing the modern technology. And also there is some limitations. Hope our future innovators will fill the gap. And also the future scope, which is already told that there is some limitations. We have to fill the gap. Resonant wireless charging, longer range. Now we can nowadays we can charge the device in a shorter range, like attached to a device. But in future we can charge the device with a longer range and multiple device charging at a time. And dynamic charging for EVs while moving. That means while moving the car or EVs, that times also charging the battery. Smart power management systems. This is our future scope, and also and the last slide you can see that wireless charging is smart and convenient technology that uses electromagnetic induction to transfer power without cables. Though it still faces limits like slower speed, short range, new innovations such as MagSafe and QI2 shaping a faster and smarter wireless future. I previously said that MagSafe and QI2, this is the new technology, which is the best of QI standard. So this is the future. This is our future technology, and we should have to make many opportunities to deal with this, and also have some limitations. I hope these limitations will one day we will fill this gap. Thank you very much. Assalamu alaikum.